Hi everyone, welcome back to Falcon's House. This is part 2 of my PC upgrade series. If you haven't watched the first part, I recommend that you check it out while I explain my case and airflow design. In this part, I will talk about water cooling. My current system is the first one that I did water cooling with. The primary reason I switched to it from air cooling was noise. I was working from home a few days a week at the time, and when I would be at idle, the noise from the CPU fan would slowly get annoying the longer it was on, only the background noise. So I'd have to play music over it just to cover the noise. One of my first videos on my channel was adding sound dampening material to my case. When I was gaming, the GPU fans would spin up loud enough that I would have to turn up the volume on my speakers or wear headphones. And I am not a big fan of wearing headphones because they push my glasses into my head and make it uncomfortable for long sessions. Water cooling gave me a much better noise profile, even if it isn't silent due to the power supply fan. As an added benefit, it also allowed me to overclock my GPU a lot farther than I could on air. I think for most people, it is probably an unnecessary expense, and the risk of a leak is higher than what an all-in-one cooler would get you and an all-in-one would be 90% of the performance for a quarter of the cost. But since this was built prior to the proliferation of good all-in-ones, it made sense at the time, and that it makes sense for me to continue with custom water cooling as I've already spent the money on a lot of the components. My original set of water cooling components was around $800 for a D5 pump, a Hardware Labs Black Ice 480mm GTX crossflow, which is 30mm thick and then 4 by 120mm fan configuration, with EK Vardar F2 fans, which are no longer produced, but they are PWM fans that go between 750 RPMs at idle and 1450 RPMs under max load, and typically run around 1200 RPM during gaming. Then a reservoir, fittings, tubing, anti-growth and corrosion fluids. At the time, the rule of thumb for radiator sizing was 120 millimeters per radiator, per component cooled, and an extra for overclocking. Since I had both a CPU and GPU overclock, I went with a 400 millimeter radiator size. This is not the best way to size radiators, as I have now learned. The proper way to size radiators is by the heat output of the components. Extreme Rigs has a very in-depth comparison from 2016 of 360mm radiators, and unfortunately has stopped doing reviews of radiator components. However, since the technology doesn't change very much, you can still use the data. EK also has a configurator on their site for their radiators, which is fairly accurate, but it doesn't seem to list the fan speeds from what I can find, and that I assume that they are using 2200 RPM fans for the silent option and 3000 RPM fans for the overclocking option. I don't want fans that loud though, so I base everything on 1300 RPM speeds from the Extreme Rigs tests. Their goal was a delta T of 10 degrees, which is fairly standard in radiator reviews, but not necessarily what you need to achieve for good cooling and for good performance. Delta T is the difference from the ambient air temperature to the water temperature. They tested radiators at 750, 1300, and 1850 RPMs, along with a flow rate of 0.5, 1, and 1.5 gallons per minute of flow rate. In general, flow rate was a small increase in performance, and typically you can just set your pump at a fixed speed at 50 or 60%, maybe even lower than that, and that is enough to give you the best performance. They primarily tested with fans in a push-pull configuration, which is best for cooling, but is only about a 10% performance increase for double the cost of fans, and it makes it harder to fit in the case. Since a 480mm fan should be around 25% more cooling capacity than a 360mm fan, using that number for my radiator produces around 201 watts of cooling capacity at 750 RPM and 332 watts at 1300 RPM. So an increase in fan speed of around 73% increased the cooling capacity by about 65%. And scaling up to 1850 RPMs was a 42% increase in fan speed for an extra 25% in cooling. So there are diminishing returns the faster the fans go, and obviously more noise. So if I conservatively add 6% to my cooling capacity for 1450 RPM fans, that brings it up to right around 350 watts of cooling capacity for a delta T of 10 degrees. Using my power draw numbers for my UPS, my system uses around 380 watts during gaming, so my system is more or less at the limit of its cooling before the delta C starts going up and there's a bigger temperature difference between the air temperature and what my water temperature is actually running at. And the higher it goes, the less it can cool components, and so if you vastly undersize a radiator, the temp's going to keep increasing because it can't remove heat from the loop fast enough before more heat is added. But my setup is not this. It can safely handle it. It's probably more like a delta T of 15 degrees or so, which potentially is limiting my max overclocks from 4.7 or 4.8 gigahertz down to 4.6 on my 4790K, but that shouldn't be a problem going forward. Anyway, after that long explanation of radiator sizing, I wanted enough cooling capacity for the best possible new parts. And the new top-end NVIDIA card is rumored to use 350 to 450 watts by itself, and a top-end AMD CPU can be around 225 watts. So I sized it to around 675 watts. I'm adding a second 480mm GTX non-cross-flow version, which is about 10% better than the one that I currently have, and will move my cooling capacity to 440 watts at 750 RPM and 695 watts at 1300 RPM. The new fans that I added are NB E-Loop 1500 RPM fans that go down to a 600 RPM at minimum speed. So my max speed cooling should be around 740 watts. EK's estimator for dual 480mm radiators has it around 1200 watts, and so adjusting for span speed, if they're using 2200 RPM fans and I'm using 1500 and 1450 RPM fans, has it around 800 watts. So my other math sounds about right. And they estimate a delta T of 4.5 degrees, which probably is too low. It's probably going to be that low at idle, but probably not that low under load. But that's extremely overkill, and I can probably run my fans at minimum RPM most of the time, even under a gaming load, because most likely most games aren't going to max everything to its absolute limit, and where I'm pulling the max amount of power. I realistically will probably never need to upgrade my cooling again, no matter what hardware comes out in the future. Now, there is some interesting stuff that has since come out since I originally wrote this script, and that is that the peak potential power draw of the 3090 of the new GPUs from NVIDIA could be as high as 600 watts when overclocked, but that is peak draw for a couple seconds, not sustained load. Sustained load's probably still only 450 to 500. Even when overclocked heavily, so I should still have enough cooling capacity because with that much water in my system, I should be able to maintain the lower temps to handle those spikes. I mean, theoretically, if I don't, I can always add another 280mm or 360mm radiator, and that would bump me up even farther, or I could get faster fans. So there's still options if I had to upgrade again, but I don't think I will, especially since at idle, I can probably run very few fans or no fans at all. So the other parts of my water cool, the other changes to my water loop are an Optimus PC's AMD water block, which has great reviews and should allow me to pull as much heat away from the CPU as possible. And I am switching to Mayhem's Biocide Extreme and Inhibitor Plus, and these are very concentrated and only require a single drop per liter of water versus 100 to 250 milliliters of additive for other brands that are less concentrated. They also allow you to just, off the top of the Biocide with an extra drop every 6 months instead of draining the full loop to add more. The other big changes that I am making are adding an Aquacomputer Octo fan controller, an inline water temperature sensor which will allow me to adjust fan speed based on the water temp, and also because it has a USB connection to the CPU or GPU load rather than just doing it on the CPU temperature like I do today. This should allow me to run fewer fans and not just ramp up for a short high CPU workloads. If it goes well at idle, I may be able to just run 2 fans at 600 RPM and add fans as the water temperature increases before increasing fan RPM or adding more fans, allowing for an even quieter system. This will get its own video once everything is built. And the last thing I'm doing with the water cooling is replacing the O-rings on all my fittings to increase their lifespan and reduce the chance of leaking. Anyway, the one thing I wanted to go over on this other screen is how their diagram for Extreme Rigs' test is set up. So here's the Hardware Labs 360 GTS that I have now, and they tested it at 0.5 gallons per minute, 1 gallon per minute, 1.5 gallons per minute, and push only in 1 gallon per minute, which is how I am using it. In that configuration, I might be a little bit above or below 1 gallon per minute, but close enough. So it's 750 RPMs. Their 360 can do 160, at 265, and then 344. There's a big jump here, but it's a lot more noise and a lot more. So theoretically, going here is probably the best option. I could really maximize my cooling, but I don't think it's necessary. Like, once you start adding in, this will be 30% or 25% more to be a 480 milliliter radiator, and I'm adding this as well at 480 millimeters. The idle power draw is probably going to be 100 watts. It's going to be super low, and under load, I can probably just run it like under light loads, like a game that isn't pushing my system super hard, which will be, there's plenty of games that I've tested that fall into that category, and I'll have more games tested. And there's also, like, even big releases potentially are not going to be pushing it hard because they're going to be capped at 60 FPS or 90 FPS. They're not actually realistically going to be able to get me to 120 FPS in ultra wide or 4K 144. I've upgraded my Eve devices order from the 1440p 240 Hz to 4K 144. I just feel like that's a better option for connecting consoles to, because consoles are going to want to do 4K and not 1440p. So that's why I chose that. In addition, I'm also getting an HP Reverb G2 VR headset, which does 2160 by 2160 in each eye, which is pushing about as hard as the 240 Hz 1440p display at about 890 million pixels per second. 4K 144 is about 1.1 billion pixels per second. And so even with like a top-end 3090, I might not be able to still push those resolutions at full speed, at full refresh rates or anything like that, but we'll find out soon enough. I'll have a separate video on the video card later on. But even looking at these things, there's no reason why I can't cool everything at idle on very low fan speeds, and even ramping it up to 1300 or 1400 or 1500 RPM. It doesn't make it super loud. It's still quieter than my old system with air cooling with an 1800 RPM CPU fan and 3 GPU fans on when it was air cooled. Those are much louder. So realistically, I should have a nearly silent build. Like I said before, only the power supply fan is really where my noise comes from, and everything else should be pretty much quiet, and that should be great. Anyway, thanks for watching. Please like and subscribe, and I'll have more upgrade videos coming for the remainder of the parts.